let's see what we can get into. And then I'm just gonna, I think you're probably familiar with Desmos. I'm a bit, have you used Desmos at all? No, yes, no, yes, some yes, okay. I love Desmos. You know I complain about Texas Instruments a lot in here. I do love Desmos because you don't have to have the equations solved for y. You can just type them in as given. And I'm going to show you, and you'll see it on the homework. So I'm going to have you look at some problems graphed on Desmos because obviously that generates a lot better, prettier pictures than what we're going to hand draw and sketch. And there's kind of some neat graphs in there. But I'm going to show you how to use it. It's super easy. So really today we're going to look at like 3 different types of polar graphs. We're going to do super easy circles. Minus I can't draw a circle that great. We'll do our circles. We're going to do what's called a limacon. Those are kind of fun. I like those. And then we're going to draw what's called polar roses. The roses aren't bad either, except my lack of drawing skills, obviously. And those take just a little bit more calculations. You might want to have your calculators out just because we have to do some simple math, like we got to increment, like how often we're going to draw a polar leaf on it. So you might want your calculators just for some little basic math. All right, well, let's do circles. Now, circles to me obviously are the easiest, except hard to draw a circle. Remember, of course, everything is kind of related a little bit to the last 2 chapters because you're going to see some sine and cosine in these equations. Cosine, remember, always are x coordinates left and right. Sine, of course, are y coordinates up and down. So that's going to help us when we draw our circles, of course, and our limacons when we get to those. All right, so your equations, of course, today can be 2 different styles. You can have a, times the cos of theta, and then we'll look at when you have sine of theta, how it changes. So of course, a is super easy. A just represents your diameter of the circle. And remember, we just kind of reviewed it, cosine is your x. So these are going to be moving horizontal, left and right. Obviously, if I throw sine in there, which is what we're going to look at next, they will move up and down. So if we wanted to draw this, if a is positive, it's going to be over here on the right-hand side. We're going to put some numbers in. We're going to draw some actual circles. Lord help us. See how steady my hand is today. So it would be on the right side. And then, of course, a is your diameter. So if my diameter is 10, make it a width of 10. Up 5, down 5, left 5, right 5. And we'll draw some. Now, of course, if a is negative, it's going to move over here to your left side. That kind of got an oval on me. And of course, a is your diameter. So let's draw some with actual numbers in them. Circles, like I said, pretty easy. So for cos theta, so let me just draw a little x and y axes here. So we're just sketching these today. So first up, I see the positive 4. So I know that's going to put it on the right. So I'm going to have my circle over here on the right, but of course it's going to be a little more accurate than just the generic sketches we did. So diameter of 4. 1, 2, 3, 4. So I know it's going to be that wide. I also, of course, remember your diameter also runs vertically, of course, through it. So to get my diameter of 4, I'm also going to go 2 up and 2 down. So if it kind of helps, I mean, think of your center here of your circle would be, of course, in the middle. Oh boy, I'm going to try to 2 up, 2 down. I'm going to try to draw myself a circle around all of that. Not too shabby. Not too shabby. Could be better, could be worse. And then, of course, all this one changes. Like I said, we don't have to spend a lot of time on circles. So, of course, because you have the -6, that's going to put it on the left side. So, of course, we're going to go 6 over here. 1, 2, 3. 5, 6. So that will give me my horizontal diameter. But of course, to get the vertical, a total of 6, I'm going to go 3 up, 3 down. 3. That's going to be the top and bottom, my left and right. Glad I picked such a big number, 6. Could be better, could be worse. Okay, so any questions on drawing horizontal circles, left and right? Now, you probably, without me, could figure how to do it if you put sine in the equation. Because, of course, sine now just moves them vertical. So sine, of course, we know represents y. And, of course, if it's positive, your circle is going to be up here on the y-axis. So I'm going to say directed up. So, again, just to give you kind of a general generic sketch, it would move up here. That's not too bad. Okay, and, of course, negative, it's going to move it down. So, of course, switch it to here. So we're just going to sketch a couple, of course, with some real numbers, but again, circles are pretty easy if you ask me, okay? Minus my lack of drawing skills on the circles. All right, so kept the number small, except I kind of regret the 8 on B, but we'll make it happen. So of course, sine, you have to think vertical, of course. So positive 2, 2 for a diameter. And then of course, if I want 2 for a diameter for the horizontal, I'm going to go 1 and 1. All right, so top, bottom, got a diameter or 2 all the way around. Pretend I hit that point. All right, and then let's do, of course, I don't know why I picked 8, I regret that. So because it is negative 8, I know it's going to go down in a diameter of 8. I'm going to kind of skew my graph grid a little bit. I'm going to put this x-axis up a little higher, just so I have plenty of room to sketch out 8. 1, 2, 3, 4, 5, 8. So I got my top and bottom. And then, of course, to get the horizontal, we need 4 left and right. So my 4. Let's see if we can make it through here. Now, I've heard this pronounced like 10 different ways. I've seen it called a limacon, limacon, limacon. I've seen it all. I call it a limacon. You call it what you want. So these are kind of fun graphs. I like these. Except my lack of drawing. Okay, so for these, of course, notice your equation changes obviously from the circle. You're going to have, some sort of number added to it. So that's why it kicks it into a limacon. Like you're going to have 5 plus 2 cos theta. So that's the shift on it. So of course the plus or minus, that affects direction. So again, just to make it easy, remember, cosine's always horizontal. If you have a positive cosine, it's going to be on the right side. Negative cosine, left. Positive sine, it'll be up. Negative sine, it'll be down. So it all works together. Now, I thought, let's take a look at some nice digital pictures versus my hand-drawn, so you kind of get an idea what it is we're actually after. The most common two we're going to draw are these first two that have what we call an inner loop, and then a cardioid. Kind of has, kind of looks like a heart. The other two are, I think, hard to draw by hand to get just that little dimple, and that one almost turns to a circle. So really the ones we're going to draw mostly are these guys. And I'm going to get into all of the drawing. But what we got to look at here is this part. So A and B, of course, is on our equation. If you divide it out and it's smaller than 1, you're going to have an inner loop. If you divide it out and it equals 1, and you'll see why when we get into drawing them, you're going to have the cardioid that looks like a heart shape. Now, just to be crystal clear too, we talked about the plus or minus, bless you, affects the direction. So I know cos is horizontal, positive, of course, right. A negative cos will open where? Will be on what side? Left, yeah. Sine, of course, is our vertical, so positive sine, it's going to be up. Negative sine, obviously, down. All right, here we go, my artistic skills, it's going to be good. Okay, sketch a graph of the following. Now, first off, A, it's not a circle because you're adding that value of 3 in the front. If you just had 5 cos theta, then it's a circle. Clearly not. I see we have positive cosine. I'm looking at that 5 in front of cosine, so I know it's going to be opening or towards the right side of the graph grid when we draw. Now, first thing we got to figure out, A and B, if it's going to be the inner loop or the cardioid. So I always divide A and B. So you have to be a little good with fractions. The question is 3/5 less than 1? It sure is, okay? So I'm just mentally thinking here, we're going to have one with an inner loop. And I'm going to show you how to draw. So it's going to look like this. Actually pretty close to this one. Clearly got to get some numbers on it. I say pretty close because ours is going to be on the right because of the positive cosine. That one's on the right. So it's going to look pretty similar to that, to be honest with you. Okay, so to figure out, because clearly we need some numbers to mark on the graph here. We can't just kind of Hail Mary this thing. So two things you have to figure out. Our x-intercepts and our y-intercepts. I'm going to do x first. So x-intercepts, and again, once you get these, like it's super quick, we don't have to get carried away and do so much writing here. But to get your x-intercepts, first you're going to add a and b. So if I add 3 and 5, and again, eventually we won't be writing all this out, we'll just do it. So first I'm going to mark out to 8 here. Okay. And then to get your other x-intercept, you're going to subtract them. So I'm going to do b minus a. Because I want it to stay positive. That's why I didn't do a minus b. I want it to be on the positive x-axis. So 2 would be my other one. All right, to get our y-intercepts. Those are easy. It's just a, plus or minus a. So they're going to be at 3, 0, or 0, 3, sorry, 0, 3, if I'm going to write them ordered pair style. 0, 3, and 0, negative 3. All right, so 1, 2, 3. And again, eventually we don't have to write all this stuff out. We can just mark it. So when I look at this, I'll be honest, I never write out all that stuff on the right. I'm just like, oh, 3 plus 5, I know it's on the right, 8, 5 minus 3, 2. 3, of course, is going to be the y-intercepts up and down, and I do it. Okay, here we go for my graphing skills. Are we ready? So my advice, okay, start at the origin, because we want it to look like this. So pretty much I'm going to kind of do this. I'm going to go to the 2, I'm going to circle around to 8, and come back up. All right, so here we go. So I'm going to get my inner loop, ready for the inner loop. There's my limacon. How's your artistic skills? And this is why I'm going to have you look at some on Desmos so we can get some nice, pretty, accurate pictures versus my hand-drawn ones. But that's as wild as it gets. And like I said, I don't expect you on a quiz or test to write all this stuff out on the right-hand side. You can just look at the equation and do it. But clearly our first time, I'm going to write them out. All right, first up. So again, here we go, guys. I like we're looking at each other's graphs. So first up we have to decide, is it the inner loop or is it going to be the cardioid? Yes, there's 4 total types, but remember we're really going to focus on those first 2 because the other 2 are very hard to sketch. So again, I'm looking at my a over b. 2 over 5 is less than 1, so it is going to be another inner loop. And again, I don't generally get crazy and jot all this stuff down. I just look at it and like, oh yeah, 2 over 5, less than 1, it's an inner loop. Now this time though, I got fancy and gave you a sign. So I'm thinking vertical, and the coefficient on sine's -5. So it's going to be down. So I don't want to say I quote unquote skew my graph, but because I know it's going down, I'm going to kind of on purpose put the x-axis a little higher so I have a lot of room down there. Now, like I said, we don't have to get crazy. I usually don't write out all of this stuff, but you can just look at the equation and do it, but I'm going to do it. So since it opens down, we're going to start with our y-intercepts. We're going to mark on the y-axis. So we're going to do a plus b, or in our case, 2 plus 5. Now, but since it's down, I'm going to go 7 down. 5, 6, 7. And then we're going to subtract them, but we know it goes down, so I'm going to put it on the lower part here. So I'm going to do, of course, b minus a.
Why are we doing like the y-intercepts, the x-intercept stuff now?
Because it's sine. It's switched. That's why. Because you got to keep it on the y-axis for sine. And again, I was 2 minus. So I just look at that, and I'm like, 2 minus 5, yeah, it's -3, okay. 2 plus 5, yeah, 2 plus 5 is 7, but we're going down because of that negative, so I just put -7 on there. I don't ever even write this stuff out. I go, yeah, okay. So now, of course, we got where it's going to hit on y. We need where it hits on x. Well, x-intercepts then is that the a. But since it's x, if you want to get crazy and go ordered pairs, which I usually don't even write it, I just go 2 right, 2 left. So 8 is always your other axis intercepts. And it all hinges, of course, over sine and negative sine. So that first term is the other axes intercepts. Jack?
Is it 7 or -7?
Well, it's going to be down because you're going down because of the negative on the 5. That affects it. I don't care if you add A and B, subtract A and B, whatever.
Well, you wrote 7 for the y-intercept. Is it 7 or negative 7?
Well, because of the negative lead coefficient, it shifts it down, so it's going to be down on the lower y-axis, so negative 7.
Okay.
I'm just putting the values together. The negative on the 5 dictates where I'm putting those. Carter.
Wouldn't the B minus A be positive 3?
Who cares? I know because of the negative 5 on the sign, it's on the negative y-axis. So you're finding that, I mean, I guess if you want to really get technical on it, boy, you guys are making this hard. If we want to get technical, of course, so, which I don't know why you guys are making this so hard. Just add A and B, but I know it's going to be on the y negative axis because of the negative 5 on sign. Then I subtract A and B. I don't know if I marked that even. Yeah, negative 3 is going to be on the negative sign. Now, if you want to get technical up here, I mean, I could write every option. You know, it's going to be B minus A if you have a positive sign, B minus A if you have a negative sign. It's going to be A plus B if you have positive cosine. It's going to be A minus B if you have negative cosine. I can put all the options on there, but why? It's this that's determining where to put it. And then the other value, of course, is your x-intercept. So the 2, 0, negative 2, 0. Now, same thing. I'm going to start at the origin. So before I draw it, you try to draw it. I'm going to make the inner loop, and then I'm going to hit the intercepts. So I'm going to start at the origin, my inner loop. It could be better, could be worse. Could be better, could be worse. All right, ready for the next one? I'm scared. All right, so things you got to look at first. What's A over B? 3 over 7. It's less than 1, so it's another inner loop. Just for the record. Now, this time, you have cos in your equation. What's your coefficient on cos? Negative 7. So which side is this going to be on? Top, bottom, left, right? Left. So once, and you can see, like, I don't want to say I'm shifting my graphs because I'm really not, but I know it's going to be on the left, so I kind of made a longer left axis. Now, here again, I don't generally stand up here and write out A plus B, A minus B, B minus A, or is it B minus I? Who cares? I do 3 plus 7. I look at the numbers. First I add them with 3 plus 7. But left, so it's really a negative 10. I regret making that so big, but okay. Got it? And then I do, what's 3 minus 7? 4. Or ooh, what if you did 7 minus 3? It's still 4, but we know it's on the left because of the negative cosine. Okay, so we got the y-intercepts. We got the x-intercepts. What's the y-intercepts? 3. We're going to go 3 up, 3 down. Okay, and then same thing. I'm going to start at the origin. I'm going to draw my inner loop first and then hit those intercepts. Don't judge my artistic skills here. Not bad.
You wouldn't ever give us points off for our graph on being like circles, right?
No, since we're sketching, I'm happy. No. Okay, any questions on that guy? And you don't have to write the intercepts or anything out. You just got to mark them and get it drawn. All right, one more of these before we hit the roses. Okay, A over B, you always start with that. What's A over B? 1. So, just to mix it up, this one's going to be a cardioid. Now, here's the thing. You know, because there's so many little details here, I don't get oh gosh, is it inner loop, cardioid? Here's really easy, you'll see why it's going to be a cardioid too, if you can't remember. So I'm just going to put cardioid. Now, it's still the same process on drawing the graph, okay? It's still the same setup, it's still the same thoughts. Cosine, so I'm thinking horizontal, positive 3 in front of cosine, so left or right? Right, okay. And 3's not so bad, so I'm not so worried about it. Now, I'm doing the exact same thing. Here's why it's a cardioid. I'm first figuring out my intercepts over here. So I'm going to add A and B. What's A plus B? 6. So I'm going to go 6 over. Now here's why it's a cardioid. What's A minus B? 0. So that's why we wouldn't have an inner loop on it, okay? Now, same thing. You've got your x-intercepts. What's the y? 3. Up 3, down 3, the first term. So this is why you don't have an inner loop. 3 minus 3 is 0. So when I start drawing this, there would be no inner loop. So again, kind of here's my cardioid, Lord help me. I just have to go to the intercepts. Wait till you see the Polaroid roses when I draw those. All right, questions on the cardioid? Any other questions on the limacon before we get into the roses? The roses are easy too, it's just a little more calculations. All right, let's talk polar roses. Now, this is what they look like. I always have to give you a digital picture versus my hand-drawn. This is what they're going to start looking like, okay? So, here's the difference. Here's the difference on your equation. You're not adding or subtracting anything to sign, okay? They look like a circle equation to me. They look very similar to the circle equation, except one subtle difference. On your circle equation, theta was just theta. It was 1 theta. These are going to have coefficients on them. So that's really, it's tiny, but that's the difference. From a circle to a polar rose, you are going to have a coefficient on theta other than 1. That is the difference. Now, oh, how many leaves? Okay. I always pray for n to be odd, because that's just how many leaves you have. If n is even, you have to double it. Okay. I don't know why last year I didn't put it in because my drawing's so bad. I don't know why I put 6 in here last year. There was 12 leaves. I was like, that was a fail on my part. I took that one out. So if it's an even number, you have to double it to get the amount of leaves to draw. Now, it's easy to draw it. Obviously, we just got to talk about the setup here and how to do it. A, the lead coefficient, kind of like the circle. Remember on the circle, A was the diameter. A is going to tell you how long the leaves are. So if your coefficient's like 5, each leaf is 5 units long. So that's how we're going to draw these. Okay, so just to kind of give you some general information here, we're going to draw some separate ones in a minute. Let's talk about the cosine first. So of course I see the 3. Okay, yeah, it's odd, so I know that one would have 3 leaves. Now the key is, of course, how to find that. Okay, for cosine, one of your first leaves, I like cosine, one of the first leaves is always on the positive x-axis. So I'm going to put first leaf, positive x-axis. Now, you know I can't help it, I got to talk about the y, just not, we're going to slap it on there. Here's the y. So if you put in 0 for theta, what's 3 times 0? 0. What's the cosine value of 0? So think about your quadrantal point. 0 degrees is at the point 1 comma 0. Which one represents the cosine, the 1 or the 0? The 1. 1 times whatever this would be is going to be your first leaf. So that is why this all hinges from cosa 0 is 1, for whatever you wanted to know. Now I cringe on this other one because it's even here, 4. So this one would have 8 leaves. And of course the first one is still on the positive x-axis. Now let's talk about how do you find the other. How many degrees are in a full circle? Because we're going to work in degrees. How many degrees in a full circle? 360. So to find the remaining leaves, we're just going to equally scale it. So this one had 3 leaves. So every 120 degrees, I would draw the next leaf. So, I mean, that's easy to mental math. You're going to have one at 120. At another 120, it would be where? But of course, you might want your calculator because we'll have some decimal ones. Because I'm like, oh, Lord. To get the remaining leaves, you would have to, because there's 8 of them, do 360 divided by 8. What's 360 divided by 8? 45. So now every 45 degrees, I'm going to draw a leaf at 45, 90, 135, 180, 225. I'm going to keep adding 45 to get all my leaves. It's gonna be fun. Okay, sine. I like the fives, the odd 5 leaves. So the number amount of leaves, that works the same regardless if you have sine or cosine. Here, of course, the double, I'm gonna have 4. Okay, so for this one, a little different to get your first leaf, okay? To get your first leaf, not leaves, so busy writing leaves. Okay, to do your first leaf on this one, you're going to do 90 divided by, and this one would be 5. So this is where you would need a calculator. I punched it in earlier. And of course, okay, I can't help myself. I'm going to talk about the y here for a second. So here's the thing. If you put 0 in for theta, 5 times 0, 0. Okay, so I'm thinking about where is sine 0? At the top and bottom. So that's why we're going to start just at the top at the 90 degrees. That's where the 90 degrees from. It's from when you're solving sine equals 0. And of course, this has 5 leaves, etc. Now, to get the remaining ones, it's still the same thing as on cosine. A full circle is 360. Let's see if I can sneak it on here. So I'm going to put remaining leaves. We're going to do 360. Let me move this up so I'm not at the bottom. So do your remaining, we're going to do 360 divided by 5. Hang on a second. Do we all have the same question? What do you got?
That's 18.
Oh, is it? Sorry. Sorry, guys. Sorry.
Welcome, Mrs.
Thanks, guys. Sorry. So sorry, guys. Like I said, I really don't feel very good at all. So you're going to do 18 degrees, and then we're going to add whatever this turns out to be. What's 360 over 5? Now I don't trust myself. What is this? What is it, Spencer? 17? 72. So I'm going to draw the first leaf at 18 degrees, then I'm going to keep adding 72 and go around and get them all. Okay, 4 leaves, of course, it's the same thing. You're going to do your first leaf. You're going to do 90 divided by 4. All right, what's 90 divided by 4?
23.5.
Or, I'm sorry, 90 divided by 2. You're going to just use your coefficient. I'm sorry.
Oh.
I know.
Stop spraying stuff in my hair.
And then to get the rest of the leaves, it's 360 over, there's 4 of them. Here, and I'll answer, I saw a hand up, I'll answer it in a second. So notice, of course, on the sign, the odd is easy, of course. To get your first leaf, it's just the 90 over 5. But here, of course, you're even. You're still just doing the 90 over 2. You're doing the coefficient on theta. I have chalk on me. And then, of course, you have to divide 360 by the total number of leaves. Because remember, when you're even coefficient, you're going to double it for the total number of leaves. So you're always doing 360 divided by the total. But the first leaf, it's 90 over your coefficient. But we know it doubles on the even coefficients. Did somebody have a question? All right, let's start drawing. Oh boy. Okay. So sketch the graph of the following. Okay. All right. Well, I'm gonna put the graph in here, so I'm gonna write some prep work. Okay. So first up, let's get the first leaf. Coefficient uno, right? So first leaf on sine. So I'm looking back at this, odd. First leaf, I'm going to do, of course, 90 divided by 1, which seems dumb to write, but I'm going to write it. I think we can mental math that, right? Now, the other question or thing we have to mark on this is the length of the leaf. Because now we have, of course, real numbers in here. So my leaf is going to be 3 units long. Now, here's a fun question for you. How many total leaves are there? This is kind of a fun one. Oh, Lord. Total leaves, 1. Because it's odd, you just use that value. You don't have to double it. So really, this is what type of picture? It's a circle. So even though it's in the polar rose section, it's really just a circle. All right, let me put some. So it's going to be 3 tall. How wide is it going to be? 3, which I'm going to kind of 1.5 it, obviously. So there's my top and bottom, and I'm
Why'd you
gonna
only
bulk.
do 2 on each side?
Well, because I got to go 1.5 each to get the 3. I'm gonna ballpark the 1.5. So I'm like 1.5, 1.5, 1.5. I'm kind of making it happen. That's not the best circle, but it is what it is. So just to show you, sometimes you might be in what they call the polar rose, but of course there's only one leaf. It really is a circle. Let's get something a little more exciting. Okay, so this time, got a different value for you. How many total leaves do you have on this one? 3. So, put a little note, 3 leaves. How long is each leaf? 3. And I did try to keep these numbers small on purpose because we don't want to have to get too crazy on our graphs. Now it's a sine equation, so I'm looking at this red part. To get the first leaf, I'm going to do 90 divided by, ours is 3, so let's start with that. You can mental math it. I'm going to write it. What's 90 divided by 3? 30. So my first leaf is at 30. So, and it's 3 long. So first thing I'm going to do is I kind of need a 30-degree line on here to draw it on. I'm not going to get a protractor out and measure, but I'm kind of picturing 30 degrees. That might be more than 30 degrees. I don't know, okay? Now I'm going to, of course, 3 units. So here's my first leaf. Now, we know there's a total of 3 leaves, so clearly I need to get the other 2. We want to go around a full circle, so we're evenly going to scale our full circle by the amount of leaves. So what's 360 divided by 3? 120. So the next thing I'm going to mark, and again, I'm not going to get a protractor and measure, but I'm going to put a line at 120. So I'm like 90, 120. Good enough, close enough. And I'm going to, of course, 3 units out. And I'm going to make my... Now, your last and final leaf. What's 120? We left off at 120 plus another 120. 240. So I'm going to put this one at 240. Again, I'm kind of estimating it. So I'm like 60 past 180. I can't really promise you that's that, but okay.
Why'd you add 120, not 30?
Say that again. Why did I add
Why
what?
don't you add 120 to the 30 to get the second one?
Oh, I should have. You were right. I'm sorry, guys. I'm so sick today. I really should have. You're right. You're right. No, you were right. Here. Any questions on that? That's why I'm glad I took the 12-week one off.
I like
All right, pulling it together. I regret this one. Okay. So first question for you. First question. How many total leaves? 4. Because your coefficient's even, so we have to double it. And notice, just to keep it easy on ourselves, you figured out the pattern. How long are these leaves? 3. You can see I kind of kept 3 for all of them just to make our lives easy. Okay, let's figure out the first leaf. So of course it's sine. So sine, we have to do our 90 divided by 2, which is 45. I'm going to mark 45. Let's start with our first leaf. That's kind of easy to mark. Okay, 45. 3 long. And then to figure out the remaining leaves, because we want to be in our full circle, what are you dividing by? 4, because there's 4 total leaves. So what's 360 over 4? Okay, so we left off at 45. I'm going to actually add here. What's 45 plus 90? So my next one's at 135. So I'm going to kind of, and of course, 3 long. And I'm just going to label. Okay, add another 90. What's 135 plus 90? 225. 1, 2, 3. And of course, what's I'm dropping stuff. What's 225 plus another 90? 315. That is the worst looking rose I think I've ever drawn. All right, questions on that guy? All right, I regret this one. How many leaves on this one? Oh, gosh, why?
Stop touching.
Oh, boy. All right, let's get it set up here. Now, of course, a length of 3 just to keep it consistent and even. Not that they're always 3, clearly. Okay, first leaf, we're going to do 90 divided by what? 4. What's 90 divided by 4? Oh, decimal, right? 22.5. So my first leaf is a 22.5. Okay, I'm going to estimate it. Okay, so 1, 2, 3. So I'm going to draw that in a second. To get the remaining leaves, because we want to be in our full circle, we're going to evenly divide by the total number of leaves, which is 8. What's 360 over 8? 360 over 8? 45. Okay, so I'm going to get it all set up and just draw all the leaves at the end here, because I think this is going to get a little messy with 8 of them in here. Okay, so here's where I said you might want your calculators. We're at 22.5. The next one is 45 degrees past that. What is 22.5 plus 45? Okay, so I'm going to estimate it. I'm going to mark it out to 3. Like I said, I'm going to draw them all in at the end because I'm worried I don't want them running into each other. Okay, 67.5, add another 45. Where's your next one? 67.5 plus 45.
It's not 2.5 beyond 9.
So where's your next one?
122.5.
Okay, it's pretty slight. Okay, add another 45 to that. Where's your next one?
157.5.
Mm-hmm. And again, I'm going to mark 1, 2, 3. Add another 45. Where's the next one?
She didn't finish her question. It doesn't count.
It's all right. Where's your next one?
202.5.
Okay, so I'm like 180. I'm like trying to picture 202. I regret this 8 greatly. Okay, next one.
247.5.
Yeah.
That was, she didn't even ask.
Well, we get points on the test if we don't mark out the angles.
I do need the angles labeled. Yeah.
What?
How hard is that to label that? Okay, add 45. Where's your next one?
292.5.
Okay.
Ooh, I got you, bro.
So I'm like 270, 292.
Sorry.
Oh,
I'll
boy.
stop for you.
Okay, next one.
337.5.
This looks like an adult coloring page gone wrong.
There's not one.
Okay, so quick count. Do we have 8 lines up there marked? Count them. Do we have 8? Okay, okay, I'm going to start drawing them. Here we go. I'm just going to do a little loop-de-loop around. How does yours look?
One of them might be cancer.
Yeah.
One of them might be cancer. Oh my gosh. Do you see why I took the 12-leaf one off from last year? Nobody needs to see that. All right, questions on that, guys? Couple more, we're almost done. So I just switched it to cosine. Let's do a couple with cosine, of course. Kind of starts the same. First question, how many leaves? 1. So really, this is going to be a what again? A circle. So even though we're in the rows section, they could get fancy and throw in a circle. So again, I'm not going to really overstress this. We can draw circles, piece of cake. What's the diameter, or really the length of the one leaf on this? 3. But it's going to be which side? Right. So there's my width of 3. I'm going to make a height of 3. So just because it's odd, 3, I'm going to have to go 1.5, 1.5. So I'm going to mark out 2 and just ballpark 1.5. 1.5. That's not right. Yeah, no, that's good. That's a little high for 1.5, but you got it. Close enough, right? Close enough. All right, let's do something, obviously, that's going to be a rows. So, of course, first let's figure out, first question, how many leaves? 5, because it's odd. Now, I like cosine, because remember, the first leaf on cosine is just the positive x-axis. So I don't even have to get too crazy here. I'm just going to go ahead and mark the first one, 3 out, on the positive x-axis. Always. Now, to get the remaining leaves, of course, is full circle, 360. 5 total leaves. What's 360 divided by 5? 72. So now we're going to add 72. We're going to increment our scale by 72. So I'm going to kind of estimate 72 here. And I'm going to count out my 1, 2, 3. There's my second leaf. Add another 72. What do you got? 144. So I'm trying to estimate that. Can't guarantee it. 3 long. Got it. Okay, add another 72. What do you got?
216.
So I'm estimating that, of course. 216. Okay, and we've got 4 up there. We need 1 more. Add another 72. What's 216 plus 72?
288.
Okay, so I'm at 270, 288. I'm going to ballpark it, right? We got it. So remember, cosine is nice. That first leaf's always on the positive, always on the positive x-axis because cos is 0. All of that we talked about, and then you just have to equally divide by 360 to get the rest. Not too shabby. Okay, let's do a couple more and finish this up. So first question: how many leaves?
2 or 4.
4. It's even, so we get a double. But the first leaf is still on the positive x-axis. That's not going to change. And again, 3, I don't know, I just like 3, that's why I went with 3. So 3. Now, to get the remaining leaves, full circle, there's 4 of them. So we're going to add, of course, 90 degrees on this. So let's add the 90 degrees. We got it. So I think we can mental math that. 0 plus 90. Add another 90, where are you at? 180. And another 90, we're at 270. That might be my best one of the day. I'm kind of proud of that one. Okay, how many leaves on this guy? Gosh, why do I make 8? Fail. Let's get this drawn. And again, the first one's always on the X. Okay, so we're going to 360, our full circle. There's 8 of these leaves. What's 360 divided by 8? 45. Okay, so 45, I got it. Now I'm going to mark them all first and then draw it at the end so I don't make a mess. What's 45? You got it, plus another 45. 90. Another 45. 135. Another 45. 180. Another 45. 225. Another 45. We're at 270. I'm really regretting this. And another 45. We are at, of course, 315. All right, we got 8 up here. Let's kind of start getting it drawn. This adult coloring gone bad, guys. This is what this is.